Hey guys, this is Miss Beckham. I'm going to do a quick tutorial today from Unit 1, Lesson 3 on accuracy, precision, and significant digits. You're going to have a lot of questions on your lesson and then on your quiz and then on your test as well that have to do with significant digits, and it's a little bit of a confusing topic for some people. So I wanted to do a video to give you some help with that. And then if you look at the caption on this video, I have a link to a handout that has these images in it and explains it in like just has it all written out that I made. And so if you want to slow down, print it out, or read through it yourself, sometimes it might be just a different way than reading the lesson, or a little bit easier to read than the lesson to get an understanding of the content. So you can click on that link if you want to view it as well. So significant digits is what we're going to talk about today. So the question I want you to think about is, what is the difference if these are two different engineers and they are ordering these bricks? And one puts in an order for 0.55 feet bricks, and another puts in an order for 0.550 feet bricks. What is the difference between that order? If you think about it, that's the same number, right? 0.55 is the same as 0.550 because, it's the same number. So what's the difference between those two numbers? Well, the difference is that 0.550 means that the machine that's cutting those bricks is even more precise, because this order is measuring to the hundredths place based on the location, based on that decimal right there. And this one is measuring to the thousandths place. So you may have a ruler that measures to the hundredths place, but you have to go out and buy a ruler that measures to the thousandths place. So significant digits kind of has to do with this. It's a measure, significant digits is counting only the digits that help with, that aid in the precision of a measurement. So for example, what's the difference between 500 and 500.0? Those are the same number, right? To you and me, when we're not in chemistry, we think that's the same number. But when you're measuring something, this 500 is not measured with as much precision as the 500.0. So really that 500 could have been 455 rounded up to 500, but the machine wasn't able to read that accurately. So it just rounded it to about 500. 500.0 means that the machine, or whatever it was that was measuring, knows that this is 500 and that this last digit is the only one being estimated. And so we have a way to count which digits really help with the precision, and it's called significant digits. And there are some rules with it, and I have some examples to show you. So it's not as bad as it looks. So when you're counting whether or not a digit is significant, okay, there's some rules that we have to follow. The first rule is that if the number is not 0, then it's going to be significant. So if you look at the number 134, all of those numbers are not zeros, and so all 3 of them are significant. So that number has 3 significant digits, the 1, the 3, and the 4. If you look at this number over here, 156,487.35, none of those are zeros, and so all of them are significant. So there are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 significant digits there. I'm going to say SD for significant digits. You just count all the digits. They're all significant. Okay. Another digit that's significant is a 0 is significant if it's sandwiched. So look at 12,003. The 2 zeros are sandwiched between non-zeros. There's a 2 on one side and a 3 on the other. I call it a sandwich 0. You can call it a captive 0 because it's held captive between 2 non-zero numbers. And so in that example there are 5 significant figures. 1, 2, 3, 4, 5. Okay, here's another example here, 104. This has 3 significant digits because that 0 counts because it's being sandwiched. The 91,005, these zeros are going to count because they're sandwiched between non-zeros. And so there are 1, 2, 3, 4, 5 significant digits here too. Okay. Another digit that's significant is if the 0 is trailing with a decimal present. So 230.0. These 2 zeros are trailing at the end. They're not sandwiched, but they do count because a decimal is present. And so there are 1, 2, 3, 4 significant figures there. Another example would be 81.200. These zeros also count because they are trailing at the end, but a decimal is present. And so there are 5 significant digits here. 1, 2, 3, 4, 5. 7.0 has 2 significant digits, 1, 2, because the 0 is trailing and there is a decimal present. So that is all how you count things that are significant. There are a couple situations where you don't count the zeros. So, for example, leading zeros. So 0.00012, all of these leading zeros do not count. So if the 0 is starting off as a decimal, like 0.1 or something, the leading zeros do not ever count, even if a decimal is present. So even if a decimal is present, leading zeros are never going to count. So for example, 0.0051, these are the only 2 that count. There are 2 significant digits here. Leading zeros never count. You can just cross them out in your mind, or you can write it down that way. This has only 1 significant digit because that's also a leading 0. And then the last situation is a trailing 0, like we talked about up here, but with no decimal present, like 123,000. There's no decimal there, right? There's not a physical decimal there. So there are only these 3 are going to count, and these are not going to count. And so 123,000 has only 3 significant figures, the 1, the 2, and the 3. In this example right here, these are trailing zeros, and there is no decimal present. That's a comma right there. So this only has 1 significant digit, just the number 1 right there, and these 2 don't count. 10,200, this one is sandwiched. It's sandwiched, and so it is going to count, like we said earlier. But these 2 are trailing. They are trailing, and there is no decimal present, and so they don't count. So this one has 3 significant digits. So that's how you count significant digits.